So this was June 2021 exam paper. I'll discuss, go through each multiple choice question. The number of subatomic particles present in 4 different species are there. W, X, Y, and Z are given. Which of these species are isotopic? The term isotopic means they should have the same number of the proton and they should have a different number of neutron. So same proton number but different neutron number, we call them as isotopes. So if we check W and X, they have the same proton, but they have the same neutrons as well. So these are not isotopes. This group combination W and Y, they have W and Y are having totally different protons. So X and Z have different protons. It cannot be isotope. So we are left with Y and Z, because if you see Y and Z, they have the same number of proton and they have a different number of neutron. So to check an isotope, definition of isotope, having a same number of proton but different number of neutrons. Iodine exists as one isotope of a mass 127. Chlorine exists as two isotopes with a mass of 35 and 37. How many molecular ion peaks are there in a mass spectrum of ICl3? So what are the possible in ICl3? Because you just have to make a possible combination, like we have iodine and C3 chlorine. So this will remain 127. This might be 35, 35, and 35. Like this is one possibility, that all of them are 35. Or we have, like this is one combination. You have to just make the combination and add, because the total mass. So when you add 35 multiplied by 3, which is 105, and 105 plus 27, so it will be 232. So this total mass is 232. Then other possibilities, this 127 will remain same. The other possibility, this might be 35, this might be 35, this might be 37. So we'll get a peak at 234. Another possibility, that this is 35, this one is 37, this is 37. So the peak will be 236. Another possibility, that all of them are 35, so 37, 37, and 37. So if all of them are 37, where we'll get a peak? We'll get peak at 238. So because this is the possible combination, so these are the possible combination for the chlorine. Maybe all of them 35, maybe all of them are 37, maybe two of them 35, 137, or maybe two of them 37 and 135. So how many possible peaks? Because how many combinations? 4 possible combinations are there. That's why C is the right answer. Is it clear, this question? Next, mass spectrum of a sample of element has only 2 peaks. What is the approximate relative atomic mass? So how to work out the relative atomic mass? The percentage multiplied by mass. So this is between 20 and 30, so this will be 25. So percentage will be 25 multiplied by mass 191 plus The percentage, so this is between 70 and 80, so it will be 75. So this will be 75 into 193 and divided by the total percentage, which is 100. So when we simplify, it will give us 192.5. So C will be the right answer. The percentage of the isotope multiplied by mass into percentage into mass divided by the total sum of the percentage. Which equation represents the second ionization? Second ionization energy needed to remove the second electron already from a gaseous state. So C and D are totally wrong because of solid state. Here, two electrons should not be released together. It's like energy needed to remove the second electron from a ion. So that's why B is the right. Why not A? Because A shows that the total energy needed to remove both of the electrons. But we don't need both. We need only to remove the second electron. The graph shows a log of ionization energy against the number of successive ionization of the elements. In this element, how many quantum shells are there? And how many electrons are there in the outer shell? So how to work out the number of the shells? To work out the number of the shells, you have to check the variation, like how many times uh, there is a variation or a gap occur. So if you check, this is a jump, like this is one jump. When we take log of ionization, the jump is reduced because the purpose of taking a log of the number is to reduce the value. So this group is one, this is another group, and this is another group. And it is obvious that this is the lowest, the first shell. So first shell can have 2, then second shell have 8, and the third shell, depending on how many we are left with. So 2, so if you want to count, so one shell, second and third shell. So how many shells are there? There are 3 shells. But how many electrons in the last shell? So 1, 2, 3, 4, 5. So we have 5 electrons are there in the last shell. So B will be the right answer. So whenever you read this type of a graph, the log of ionization or even the ionization energy graph, so you will start with the last electrons removed. So this is the first shell. Then this will be the second shell. And this is the third shell. So there are 3 shells are there. And in the last shell, it has 5 electrons. Because electrons always remove from the last shell first. That's why we read in this manner. Which ion has which ion has an electronic structure of 1s2, 2s2, 2p6, 3s2, and 3p6? So first you check the number of electrons. So 10 and plus, so 18. Aluminium is 13, but when it become aluminium ion, it will have 10 because it lost 3 electron, so it will have 10 electrons. Chlorine is 17. When it form a chloride ion, it will have 18 electrons. Nitrogen has 7. When it gain 3 electron, it will have 10 electrons. Sodium is having 11. When it lost 1 electron, it will have 10. So because the configuration shows that this is a configuration for an ion which is having 18 electrons, so that's why B is the right answer. For any question, if you want me to repeat any part, just let me know in a chat, so I'll repeat that question. What is the relative formula mass of a hydrated sodium carbonate? So how to work out this? So sodium is 23 multiplied by 2 plus carbon is 12 plus oxygen is 16 multiplied by 3 plus 10 water molecules are there. Hydrogen is 1 multiplied by 2 plus oxygen is 16. So you just have to sum. And that will be the final mass of this compound, which is equals to 286. So D will be the right answer. Which of isoelectronic ions has the largest radii? To compare the largest radii, you have to compare the number of proton and electron. Like if proton should be less and electron should be more to have the largest radii. Like in case of a sodium, sodium will have 11 protons and 10 electrons. Sodium ion. Magnesium is having 12 protons and 10 electrons. Oxygen is having 8 protons and 10 electrons. And fluorine is having 9 protons and 10 electrons because all of them are isoelectronic. So if the proton is more, the one which is having the highest proton will have the smallest size. So which ion in this combination will have the smallest size? So magnesium will be the smallest. Because there are more protons, so each electron experiences a greater force. And which ion will have the largest size? The one which has the least number of the proton. So which is having the least number of the proton? Oxygen will have the least, is having a least number of proton. So oxygen will have the largest size. That's why C will be the right answer for this. So whenever you compare the ionic radii for isoelectronic ions, isoelectronic means like they have the same number of electrons. So you will compare the proton with electron. Electron will be same. So the one which has a greater number of proton will have a smaller size. So more proton, size small. Small number of less protons, greater size. Which ion is the most polarizable? Polarizable means which can be polarized easily. Positive ions cannot be polarized, so A and B are not cannot be an answer. We're left with C and D. Chlorine is having a smaller size and iodine is having a large size, iodide ion. So the ionization depends on because most polarizable means which can be polarized more. So which ion can be, because chlorine is having a smaller size, so electron distribution can be disturbed but less. But if there is iodine, as it is having a large size, so the valence shell electrons or the last shell electron experience the least repulsion, so they can easily be polarized. And if the question was which ion cause a greater polarization, then the answer should be magnesium, because magnesium is smaller in size as compared to calcium. So positive ion, which is smaller in size and carry a greater charge, can cause a greater polarization. But the question is not which cause the greater polarization. The question is which is the most polarizable, like which can distort more. Which substance has a giant structure? So it's obvious diamond is there, which is in giant lattice of atoms. So this is about when we talk about ice, which is a molecule. So this has a molecular structure. When we talk about polyethylene, polymer contain a long chain, but it is not a lattice, like not a regular arrangement, because there are different types of polymers as well. Low density polymers are there, high density polymers are also there. So they don't have a lattice. And sodium chloride, it is having a lattice, but it has a lattice of ions. So if it was a lattice of ion, then we'll mark sodium chloride. Which compound has a bond that is the most polar? So bond polarity depends on the electronegativity. Electronegativity, as we move across the period, it increases. And as we go down the group, it decreases. The most electronegative elements in the periodic table are nitrogen, oxygen, and fluorine. Fluorine is the most electronegative. So here all of them bonded with hydrogen. So we are left with two. We are left with nitrogen and hydrogen, and we are left with hydrogen and oxygen. So these two are totally wrong because these are the most polarizing, the atoms which cause the greater polarization or maximum polarization. Like when they share the electron, the shared pair of electron is attracted towards them is more. So in this case, as we know, the electronegativity increases across the period. Oxygen is more electronegative than fluorine, than nitrogen. As a result, A will be the right answer. Means when the bond will form between the oxygen and the hydrogen, this bond shifted more towards oxygen. So partial negative and partial positive will be there. Which molecule is planar? So when we talk about like all the bonds in the same line, that is refers to which is a planar. So how to work out which is planar means it should not have any lone pair, because if there's a lone pair, then it will be either trigonal or trigonal pyramidal. So when we talk about SF4, CF4 carbon tetrafluoride. So carbon tetrafluoride, carbon forming 4 bond. So whenever 4 bonds are there, as you can see, whenever 4 bonds are there, remember 4 bond pair and no lone pair. So what is the structure? The structure will be tetrahedral. Tetrahedral structure, what happened in a tetrahedral structure? One of the bond is into the plane and another bond is out of the plane. The term planar here refers to like all bonds lie in the same plane. But in this case, the tetrahedral bonds are not lying in the same plane. One is into the plane, like it's a 3D structure. When we say a planar structure, it means like a 2D structure. But when we check option B, C2, 2 carbon and 4 fluorine. So what will happen? Double bonds are always in the same plane. And now, because now carbon is forming 3 bond, and planar or trigonal planar is the same thing. So what will happen? When we check the central atom, 3 bond pair, even 4 bond pairs are there, but when we predict the geometry, 3 bond pair, because this double bond is considered as one, this will be a single bond, this single. So 3 bond pairs are there, and there is no lone pair. So when 3 bond pair and no lone pair, in terms of geometry, when we overall there are 4 bond pair, but when we predict the geometry, double bond and triple bond are considered as a single bond. So what will the geometry? The bond angle will be 120. So this will be a planar. Or you can also say trigonal planar. It's the same thing. What about PF5? Phosphorus pentachloride. So there is a phosphorus, and this phosphorus is bonded with 5 fluorine. So when we draw the structure, one will be up, one will be down. So this is trigonal bipyramidal. Like these angles are 120 because 5 bond pairs and there is no lone pair. So these angles are 120 and angle between the two will be 90. This will be trigonal bipyramid. So this is not planar. And SF6, when sulfur bonded with 6 fluorine, so the structure of SF6 is because 6 bond pairs and no lone pairs, so then it will be a octahedral. Is it clear discussion? Okay. When C20 and H42 crack, each molecule produce 1 molecule of ethene, 1 molecule of butane, and 2 molecules of a hydrocarbon. So what is a molecule? So we have C20 and H42. It produces one molecule of ethene. So eth means 2 carbon C2H4. One molecule of butane, C4H10, and 2 molecules of the hydrocarbon. So you just have to count because you need 20 carbon. Out of 20, 2 are used here, 4 are used here. So you are left with 14. And so to have 14, so this will be 7 because 7 multiplied by 2, it will make 14. So 14 plus 2, 16, and 16 plus 4 makes 20. And how many hydrogen? Because 42 are there, so 4 are used here, 10 are used here. So we 14, so this we are 28 we are left with. So to have 28 hydrogen, how many hydrogen should be here? So it will be 14. So which molecule is the molecule E which is missing here because 2 E's is given. So that is C7 and H14. So it is heptene. So we just complete the equation and work out the final result. What is the systematic name of this compound? Whenever we name the organic compounds, we select the longest carbon chain and the numbering should start from a nearest the functional group. So we have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, so or 1, 2, 3, 4, 5. So means long. This is the longest carbon chain I have. And the numbering should start from a nearest, so double bond. So we have to start numbering from here. 1, 2, 3, 4, 5. So fourth position and fifth position, we have the branches and we have one carbon branch. So it will be fourth position and fifth position, it will be dimethyl. Because two groups are there, so dimethyl and 6 carbon in our longest chain, we have 6 carbon. So it will be hex and the double bond with the first carbon, so it will be ene. So if there was no double bond, then what will be our priority? In that case, we'll give a priority to the branch. For example, if this was a question and they ask, name this compound. So what we'll do, we select the longest chain. Longest chain is always the rule. We always select the longest carbon chain. And then this time we'll start numbering from here. Why we start numbering from this side? Because here we have the branch on 2 and then 3. If I start number from the left hand side, I'll get the first branch at 4. So whenever so the case is whenever you worked out, the numbering should always start from the nearest functional group. If functional group is not there, then branch. Cyclohexene may be prepared by dehydration of hexanol. What mass of hexene can be made from 12.5? So we have the mass ratio. We can simply take the mass ratio. Look, percentage yield is a practical value of a product divided by theoretical value into 100. So we want practical mass. Okay. So we have to, so if 100 is there, 100 is giving 82. So if we have 12.5 grams, how much it will give X? So cross multiply. So 12.5. So it will be 12.5 multiplied by 82. and then it is divided by 100. So we get 10.25. So theory suggests we should get 10.25 grams. That is a theoretical value. But practically how much we get, because we need the practical mass. So percentage yield is a practical value of a product divided by theoretical value into 100. So percentage yield is 51.2%. Practical value of a product, we don't know. That is what we are finding. Theory suggests we should get 10.25 into 100. So this will be multiplied. So 51.2 multiplied by 10.25 and divided by 100. So this will give us a practical value, like practically how much or what amount of a product we should get, which is about, because it will, and it is obvious it will be less than 10.25. So it is 5.25, about 1.2% of this is 5.25. So we get this amount. Is it clear, this question? In question 16, which of these gases occupy 6 dm cube at room temperature and pressure? So first what you have to do, you have to work out the moles of each gas, and then moles multiplied by molar volume, which is 24. So to get the moles of helium, helium is a monoatomic gas. So 2 divided by 4. First we get the moles. Moles equal mass in gram over molar mass. Because helium is a atom, monoatomic, so molar mass is atomic mass. So 0.5 mole. And this 0, if we need the volume of a gas, it is moles multiplied by 24. So in case of a helium, 0.5 multiplied by 24. So we get 12 decimeter cube. So it is not helium. For oxygen, oxygen exists as O2. So if we need the moles of oxygen, 4 divided by 16, 4 divided by 32, because 16 multiplied by 2, so it will be 32. And when 4 is divided by 32, 0.125, and 0.125 multiplied by 24. So to get the volume, 0.125 multiplied by 24, so we get the volume 3 decimeter cube. To get carbon dioxide is CO2. First we get the moles, 11 divided by 44. So 11 divided by 44, that will be 0.25, because like 1 by 4 is there, 0.25. And 0.25, like quarter of 24 is equals to 6. So that's why C will be the right answer. What about nitrogen? Nitrogen exists as N2. So it will be 14 divided by 28, which will be 0.5 mole. And 0.5 mole, again, we get the same answer, which is 12 decimeter cube. That's why C is the right answer. An oxide of a lead contains 90.7 by mass of a lead. What is the formula of lead oxide? So it means empirical formula we need as, so we have 90.7 and we have 16. Divide by atomic mass. The first step, it will be 207.2 and this is by 16. So 90.7 divided by 207.2, that is 0.43. So 0.437, write the four decimal places. And here, sorry, I wrote 16. It's supposed to be remaining, which is 9.3, because if you do 100 minus 90.7, so that will be 9.3. So 9.3 divided by 16, that will give us 0.5812. And there's another digit 5 is there, so I wrote that as well. Then the next step is divide by the smallest value in the combination. So 0.4377, 0.4377. So this value divided by 0.4377, we get 1.3. 1 point, like this is 1 and this is 1.327, which is 1.33. 1.33, 1.5, like 1.33. So 1.33, 1.55 cannot be rounded off. In that, because if we try to round off, the ratio will completely change. So what we do, which number I should multiply, like some student find it difficult to select a number to multiply. Simply the way is just check, first multiply both of them by 2. If it gave a whole number, then that is right. Otherwise, multiply with 3, then multiply with 4. That is a simple way to remember. Otherwise, whenever one of the values 1.33, we multiply all of them by 3. So this will become 3. And this is 1.33 multiplied by 3, which becomes 3.99, which is approximately equals to 4. So one is 3, another one is 4. So it will be PB3 and O4. That's why D is the right answer. So here we did not round it off. We multiply the simplest ratio by a number so that it convert into a whole number. Is it clear? Then propane burns completely in oxygen. 100 cm cube of a propane mixed with 600 cm cube of oxygen. The total volume of a gas. So the total volume of a gas, first we have C3 and H8 and reacted with oxygen. So ratio is 1:5. So if we have 100 cm cube of a propane, how much oxygen will be there? X. So how much oxygen will be reacted? 500 will react oxygen, but we were having 600. So how much left? This is completely used up. So how much oxygen left? 100 cm cube of oxygen is left. So unreacted oxygen is 100. Then, because this is a limiting factor, so when we find the product, we always find from the limiting factor. So C3H8 and carbon dioxide, what is the ratio between them? 1:3. Why we took C3H8? Why not oxygen? Because C3H8 is a limiting factor or a limiting reagent. So whenever we find a product, we always find from a limiting reagent. So 1:3 is the ratio. If we have 100 cm cube of propane was there, how much carbon dioxide should be given of X cross multiply? So we get 300 cm cube of carbon dioxide. So 300 cm cube of a carbon dioxide will be there and unreacted 100 cm cube of oxygen. This is a liquid. In the question, we need the total volume of a gas. So 100 cm cube of unreacted oxygen and 300 cm cube of a formed carbon dioxide. So what is the total volume of the gas which is left? That is 400 cm cube. Is it clear, this one? First, we took a ratio between the two reactants and we worked out which is a limiting factor. And from a limiting factor, we find the product. Which aqueous ion contain the largest number of, which aqueous solution contain the largest number of ions? So what you have to do, this is a concentration and volume, but volume should be, first you'll get the moles of the molecule, which is concentration 1.5 multiplied by 0.2. Why 0.2? Because volume should always be in decimeter cube. It's given in centimeter cube. So we divide by 1000. So this will be 1.5 times 0.2, which is 0.3. After getting 0.3, how many ions are there? In magnesium chloride contain 1 magnesium ion and 2 chloride ions. So there are 3 ions present. So this total number of ions will be multiplied by 3. So this will become 0.9 moles of the ions. The one which has the largest number of moles of ions, that will be our answer. When we check option B, the concentration is 0.8 multiplied by volume is 0.4. Because It should always be in dm cube. So 0.8 multiplied by 0.4, that will be 0.32. So 0.32. But what are the ions present here? Why we multiply by 3? Because we need the total number of ions. Magnesium chloride contain one magnesium ion, which is +2, and it contains two chloride ions. The total number of the ions are 3. Here in magnesium sulfate, it contains magnesium and it contains sulfate. So two ions are there. One is a magnesium, another one is a sulfate. So this will be multiplied by 2. 0.64 moles of ions will be there. For sodium chloride, first we get the moles. Concentration is 1 and the volume is 0.5. So this will be 0.5. And how many ions are there? Sodium chloride contains one sodium ion and one chloride ion. So it contains two ions. So 0.5 multiplied by 1, multiplied by 2 makes 1. And the last one, 0.25 is a concentration and the volume is 1. So this will be 0.25. And how many ions are there in sodium sulfate? Sodium sulfate contains two sodium ions and one sulfate ion. So it contains 3 total ions. So multiplied by 3. So it will be 0.75. Which contain the maximum number of moles? So C contain the maximum number of the moles. That's why C is the right answer. Is it clear, this one? So we work out the number of moles of ions. The one which gives the highest number of moles has the maximum. A sample of a seawater which has a mass of 1 kilogram, means 1000 gram is there, contains 6 exponent 9 gram of gold. So in 1000 gram of a seawater, it contains 6 into 10 power minus 9 grams of the gold. How many atoms of the gold are there in 1 gram of a seawater? So 1 gram of a seawater, how much mass it will have? X. So we cross multiply, this will give us a mass of the gold in 1 gram. And after getting a mass, we'll find the moles. Moles equal mass in gram divided by molar mass. Molar mass of a gold is 197. So after getting a mass in 1 gram of a seawater, how much gold is there? We get the molar mass and we get the moles. And then moles multiplied by Avogadro number. So we get the number of atoms, which will be 2 into 10 power 10. So first what we did, like 1 kilogram or 1000 gram of a seawater contain this much gold. So if 1 gram of a seawater, because we want